Okay, so we are going to do this a little bit different. I'm going to be recording on here. I'm not at the school, so I cannot record on my TV there. So we are going to be doing 10.4, which is the surface area of pyramids and cones. So this is very similar to what we were doing before. This starts on page 580. So we'll go ahead and start there. The first thing that we're going to work with is pyramids. So how prisms used the surface area of 2 times the base area plus the perimeter of the base times the height. A pyramid is essentially half because we just folded it in. It's a prism that's been collapsed in. So the surface area of a prism is 2b plus the pH. So remember that is your surface area of the base plus the perimeter times the height. So then the surface area of a pyramid is going to equal the base area plus 1/2 of the perimeter. And then we have this L. So the B is still the area of the base. Your P is the perimeter of the base. And this L now it's called the slant height. Okay, so that's the height of one of the sides. So if I have a pyramid, this is the edges of my base, right? If this is a square pyramid, so my base would be a square. The base area would be side times side. And then the slant height, so the height creates like a right angle between the base and the vertex. The slant height is the height of one of the sides of these triangles. So that's our slant height. Okay, so a little bit different. So here we have a rectangular pyramid. The edges are not the same. So our base, though, is a rectangle. So we have 5 feet by 3 feet. When we do this, we're going to go ahead and look at the same exact formula. So we have base area plus 1/2 perimeter times the slant height. So the base area is 5 times 3, which is going to give us our 15. So I'll go ahead and plug that in. Plus 1/2. The perimeter now is going to be this 5 plus 3 plus 5, because that would be the opposite side here, plus 3. So that is going to be 16. And then our slant height is the 6 feet. This height right here, it doesn't even matter. They could have given that to us. Let's say it's 3 feet. It doesn't matter though. All we need is the slant height in this case. So that is our 6. So now order of operations, I'm going to go ahead and say 1/2 of 16 is 8 times 6. And then I bring down all my other information. So then 15 plus 8 times 6, which is 48. And that's going to give me 63. My labels over here was feet, so it'd be 63 feet squared. Remember, our surface area is always squared. Okay, so this is example 1 that is on page 581. It is a triangular pyramid, which is a little bit different. For a triangle, remember, when you're finding the area, it's 1/2 base times height. In this case, they don't give us that, but they do automatically give us this base area. So all we really have to do is just plug that into the formula that we know. So we know that the surface area of a pyramid is the base area plus 1/2 of the perimeter of the base times the slant height. So the base area they automatically give us is 27.7. So we do that plus 1/2. The perimeter, because we have 8 meters here, and we have 8 here, it is an equilateral triangle as our base. So the perimeter would be 8 plus 8 plus 8. So that is 24. And then our slant height is this 6 meters. So again, I'm going to go ahead and do my order of operations. 1/2 times 24 is 12 times 6, and I'll bring down this 27.7. Now they give us the base area in square meters because it is the area of just that base. What we're finding is the surface area of the whole thing. So if we had made it a net, we're finding the surface area of each part and then adding them all together. They just automatically did that base area. So we have that 27.7 plus 12 times 6. 12 times 6 is 72. So we have 27.7 plus 72, which is going to give us a 99.7. And we use this same measurement over here, which is the meters squared, because surface area is always squared. Okay, let's go ahead and look at the surface area of cones. A cone is very similar to a pyramid in its relationship to a cylinder. So this right here is what we would see as the net of a cone if we were to unravel that outside and have the circle as the base. If it was not unraveled, it would look like this. Okay, so we always need our radius. If we are given the diameter, all that means is we take half of it to get the radius. So this right here would be our slant height. So we want to work with this first. This is called the lateral surface area. So lateral just means the outside, the edge. So if you're seeing a cone, this is the rounded part around the outside, not the base. So our first step we want to work with is a lateral surface area. Let's draw a cone. Okay, so let's say we have the radius equals 6, I'll go 6 meters, and our lateral height or our slant height is 12 meters. So our lateral surface area is what we're going to work with first, and that's just pi times r times the slant height, which is going to give me 72 pi. And I'm going to go ahead and leave that pi as, as a variable first. Okay. Then we can work with the base of the cone, which is the circle. And the circle, we know the area of a circle is just pi times r squared. So that would be 36 pi. Now, what we're asked to do when we're working with the cones on this assignment is to find the lateral surface area first. So that's just the pi RL. So we did the work for both. We found the pi RL here, the lateral surface area, and then we found the pi r squared, which is just the surface area of the circle. So we did both of those. Let's go ahead and multiply out 72 times 3.14. If we do that on our calculators, we get 226.08 for our lateral surface area. And then for the surface area of the cone, or the circle, 36 times 3.14 is going to give us 113.04. Now, your directions are going to ask for the lateral surface area. So the lateral surface area is that 226, and it says to round to the nearest tenth. So that'd be, we look here, the 8 would make that round up. So 226.1, and our label was meters, so it's meters squared. That's our lateral surface area. And then it asks for the overall surface area, which means I'm going to take that 226.1 and I'm going to add it to 113, because this would leave it as just 113.0. So our total surface area for the entire cone is 339.1. And again, it's surface area, so we use the meters as our label, and it's 339.1 meters squared. So you need both. This is the lateral surface area, and this is the total surface area of that cone. Okay, so this is a cone. I know it's not beautiful, but this is number 6 example on page 582. So we'll go ahead and start again with the lateral surface area, which is pi RL. So our pi, we're just going to go ahead and leave that as the variable, times our radius, and our slant height is always going to be, just as a hint, it'll be the one that's labeled in red on your cones. So times 16. So 16 times 5 is 80. So we have 80 pi is our lateral surface area. If we multiply it out, it is going to be 251.2. So let's go ahead and work now with the area of the circle, which is just all we need is the radius in order to do that. So we have pi times the radius squared, which is going to give me 25 pi. 25 times 3.14 is 78.5. Now, our lateral surface area is going to be this one right here, our 251.2, and it is 251.2 inches squared. So that's our first answer. We're looking for the lateral surface area. And then if I add that to the 78.5, I'm going to get my total surface area is 329.7 inches squared. So we should have both of those answers on our paper. We're looking for the lateral surface area and then the overall surface area, which combines the two, the circle and the outside space. So now that we have done examples of both, your assignment is here. It is 10.4, pages 583 to 584, and you're going to do numbers 3 through 18 all. Good luck.